Hey there, creative coders. This is Benjamin D. Whiting, and welcome back to the Super Collider segment of Null-state's interactive digital art tutorial series. This week we are going to pick up where we left off so long ago. We will be creating short sonic gestures intended to convey motion across the stereo sound field. Without further ado, let's get started. Before we sink our teeth into creating our sound, let's take a moment to crystallize the purpose for this sound, along with the relevant timbral qualities we should be shooting for. Back in episode 13, we created a resonant synth, one that can evolve timbrally either over time, by some external or internal control, or by some other means. At any rate, it is meant to persist for some significant amount of time in our project. What we should craft now is a sound that provides some complementary function. As our first sound was very resonant and harmonically rich, to have our contrasting sound stand out, we should create one that is non-resonant. In other words, it should not have a discernible pitch. Furthermore, our previous sound was fairly static, spatially speaking. Since our new sound is destined to be one component of a compound sonic gesture, we should focus on ensuring that it can convincingly convey a feeling of motion. Finally, it should be percussive. In other words, it should have a sharp attack and brief decay, notwithstanding the addition of reverb to enhance our sonic field. Okay, so after having completed several takes of the following, with each approaching 1 hour in length, I have opted for a different approach. Instead of constantly interrupting myself, taking the time to explain each UGen I use on each line as I type it, I'm going to explain generally what I am going to do and then type everything out. Between each revision of our function, I will address any salient details needing further clarification as concisely as possible. First, let's allocate more memory to and boot the server. Next, as we want to craft a percussive, non-resonant sound, let's utilize one of the several noise generators in Super Collider. I'm partial to pink noise myself, so let's use that for the time being. Like most unit generators in Super Collider, pink noise will happily output noise indefinitely, so in order to render it into something percussive, we will need to apply an envelope to the sound, making sure to have the envelope generator free the synth as soon as it completes. Next, while pink noise is less harsh than white noise, it nevertheless feels heavy. Let's shape the sound using a high-pass filter. Let's also set our pink noise UGen to a variable of its own. Okay, let's choose 1200 Hz as the center frequency for our filter. Now that we've achieved our singleton percussive sound, we need to use it in some way to convey a sense of motion to our audience. While we could have it simply pan left to right, or vice versa across our stereo sound field, why not incorporate distance as well and give it some depth? First, we will need to find some way to have this sound repeat over time, and the best way to do that is to set up a simple, non-interpolating delay line. Wait, what's going on? Why do we still only hear one instance of our sound? Did I make a mistake? Feel free to pause the video and investigate on your own. So it turns out that the problem is the done action in the envelope generator. It is set to free the synth as soon as the envelope completes, but here's the thing. The envelope generator is blissfully unaware that the signal is meant to be delayed, so it dutifully frees the synth before the first delayed copy even makes it to our ears. So what should we do? The answer lies in a UGen called DetectSilence. What DetectSilence does is to check to see if the amplitude of a signal falls below a certain threshold for a certain amount of time, and if so, performs a done action on the synth. So we'll need to place it in between the instruction that adds a delay line to the signal and the output of the concatenated signal. And we no longer need this. Now I will take a moment to address how I constructed the delay line. First, I used the .fill convenience method of Mix. If you remember, Mix is a class that combines a multi-channel signal into a single channel, or multiple multi-channel signals into a single multi-channel signal. What .fill does is embed an array.fill operation into Mix, allowing the programmer to fill an array with signal derived from an included function. Next, I set up a non-interpolating delay line utilizing the DelayN UGen. Mix.fill populates the specified 10 indices meant to provide 10 delayed signals with the relevant index numbers, and I utilized those in formulae providing temporal offsets for the delay. In this case, a delay arrives every 10th of a second, along with values to determine the intensity of the sound. I want the sound to recede into the distance, thus the mole value in DelayN decreases by 0.1 for each successive delay. I also shortened the attack and decay times of the envelope to allow for some space between each successive delay. It should be noted at this point that the parameter dictating the maximum delay time is a non-modulating argument that is meant to determine the size of the buffer intended to hold the copies of the signal. Unpleasant sonic surprises can occur if your delays exceed the max delay time value. A supercollider will point to memory addresses outside of the allocated buffer, and there is no safeguard built in to prevent playback. As such, entering a value larger than the maximum time you think you will need is always a safe practice. Now, as I am sure all of you heard, the dynamic shaping was hardly convincing, staying loud initially for too long. This is because of how human beings perceive loudness. A linear progression from a normalized amplitude value of 1 to 0 means that we don't even hit -6 dBFS until we get to 0.5, after which the intensity drops like a stone. A much better solution would be to assign the decay to an envelope with a quasi-exponential curve. Quasi, as true exponential curves cannot begin or end with 0. By the way, one can use the .plot instance method of env to see a visual representation of the envelope one is creating. And it's specifically env, not the envelope generator itself. So there you go. This can come in handy while prototyping and tweaking. We're getting there, but it's hardly a refined gesture yet. Aside from getting quieter, the sound itself is still pan dead center. Let's at least have it move somewhere. Adding reverb can really enhance the feeling of our sound receding back into the void, in addition to lending to it a sense of spatial realism. Finally, let's mix in a slightly delayed copy of the signal that is run through a low-pass filter instead, in order to add volume and body to the sound. And do not forget to delete the .dupe, otherwise the panning will have no effect. For now, I have our sound moving from dead center to hard left. I also have the reverb mix go from 100% dry to 100% wet over the course of the gesture. This greatly enhances the perception of distance. Finally, to account for the reverb tail, I tweaked the time parameter of DetectSilence to wait for a full second after the sound crosses the default -60 dBFS threshold. I suppose I could have adjusted the threshold instead, but this approach works well. You may also have noticed that I tweaked the curve of the percussive envelope ever so slightly. This is certainly a big improvement. However, this synth is still far too rigid and predictable. If we want to add this as a usable gesture to our palette, we will need to facilitate customizability and, if we so desire, indeterminacy. We begin this phase of the sound design process by replacing many of our hard-coded values with arguments and variables. Of particular interest is the ability to change the attack and release values of the audio rate envelope on the fly, as well as the duration of the gesture itself. Since those parameters will now be able to be modulated, we will need to account for that in our code, including the addition of arguments and more variables. Whoa! What's going on here? What array is throwing up this serious-looking error in the post window? Feel free to pause and give it a moment's thought. So if you recall from earlier in this episode, I mentioned how the .fill convenience method of mix embeds array.fill into the mix class. Array is a class that is entirely client-side code. Now, for all of the benefits of the client-server architecture that SuperCollider gives the composer and interdisciplinary artist, it has a weakness. Values generated by server-side code cannot be understood by the client. Therefore, even though to our eyes the variable num_delays is set to the value of 1 as the argument dir for duration defaults to 1 times 10, the duration argument provides a server-side value that then renders the variable num_delays into server-side code. Therefore, when confronted by this variable, client-side Mix.fill shrugs its virtual shoulders and tells us it doesn't understand what it's being told. Replacing dir with the integer 1, as you will notice, solves this problem. So what does this mean? Are we not able to modulate the length of the synth? Will we need to craft a new synth every time we want a different duration? Find that out right now. What we need is a way to set a value in the synth externally without setting an argument. Thankfully, SuperCollider gives us a tool we need: environmental variables. We can populate a local duration variable with one that is globally accessible. Why not just use the environmental variable as is, might you ask? Well, we could, except what if one were to forget to initialize a variable before evaluating the function? We would get a big fat error message posted, that's what. By taking this approach, we can provide a default value as a safeguard against just such an event. So now if we want to change the duration, all we have to do is set the dir environmental variable tilde_dir to some other value. Now when we reevaluate, now let's add some directional variety to the gesture. Constantly panning from center to hard left gets boring and predictable quickly. Also, I feel the gesture takes too long to move to the background, so let's create a new variable that has us arrive at a fully reflected signal halfway through. We accomplish this by setting up two variables, left and right, having the synth randomly select between the two. By utilizing select.ar, when the random value generated is between 0 and 1, recall that server-side rand returns floats. Select.ar will return the signal panning from center to hard left, while a value between 1 and 2 will give us a signal going from center to hard right. Let's now add some more spatial variety by randomizing start and end points, as well as allow for further external shaping of the sound via the high and low pass filters. I think we're finally ready to enshrine our gesture into its own SynthDef. It's here, however, where we run into a problem. The reason why arguments exist at all, why we don't just use environmental variables in all of our SynthDefs for all UGen parameters, is that environmental variables are client-side code. That is, they are only sent to the server when the function itself is sent. This hasn't been a problem with function.play since each time we play the function, it is being sent to the server. This changes, however, when we save the contents of the function as a SynthDef. Certainly, the process of sending the SynthDef over to the server involves the rendering of client-side code into information the server will be able to understand, meaning that whatever value tilde happens to be set to at the time of evaluation will be preserved. Instancing a synth using the synth class, however, does not resend the SynthDef over. It merely draws from the state of the SynthDef currently stored in the server. Therefore, we will need to find some way to have the interpreter reevaluate the SynthDef without needing to do it manually. The solution? Wrap the SynthDef in its own function. I think this might be a little more successful if we have these gestures just pan from either some hard direction or somewhere a bit more centralized to a hard direction, just so that at least there's always this feeling of motion. I feel like sometimes it's being obscured if it's not moving very far. So let's try that again. So if you want to change the duration of the synth, all you need to do is change the environmental variable tilde to whatever value you want, reevaluate the function, and now it works. We can even craft a nifty function that will eliminate some of the tedious steps needed in this process. Keep in mind that we'll need to pass our environmental variables into the function as symbols. Strings or straight characters will not work. This will require the full environmental variable syntax that we've not covered by this point in the series. Please just take my word for it for now. We now have two major components of our electronic sound art project. We have a long, resonant drone capable of evolution, and we now have a gesture that can move around our stereo sound field at will. Next week, we will be focusing on crafting an impact sound to serve as gestural punctuation and possibly even formal delineation within our project. I will upload an annotated file containing this week's code onto our GitHub soon. In the meantime, please don't forget to hit that like button and subscribe to this channel to show your support for more interactive digital music and art content from us at Null-state. Also, please make sure to check out our Facebook page and webpage to stay up to date with all of our upcoming events. Links are in the description below. Happy coding!